CSIR stands for Council for Scientific and Industrial Research and was established by the first president of Ghana, Dr. Kwame Nkrumah, in 1958 to organize and conduct research to support the development of Ghana. In its present form, it was re-established in 1996 to include additional mandates. And our mandates are to conduct research, transfer knowledge, advise government, coordinate science and technology research, and commercialize the research products. The mission of CSIR and the mission has been to look at how we employ the technologies that we develop in powering our economies and to support our industries. CSIR started with several institutes, and as of now we do have 13 different institutes spread across the country. Right from Tamale with Savannah Agricultural Research Institute. In Kumasi we have 4 of our institutes. In Eastern region, we have 2 institutes and 6 institutes in Accra. And out of these institutes, 70% are agri-based and about 30% are engineering-based. CSIR has well over 500 research scientists, and that accounts for the largest congregation of research scientists in any organization in Ghana. Over the years, CSIR has developed several technologies, and these technologies have ended up with our society. The food varieties that we have in Ghana, most of them are developed by CSIR institutes such as Crop Research Institute and Savannah Agricultural Research Institute. In terms of food products, again, we have some of our products in the market, like packaged foods, developed by CSIR Food Research Institute. Animal research has got several products in the market to support the Ghanaian economy. In terms of engineering, CSIR has come up with several engineering equipment and tools to support especially the agricultural industry. Recently, we have moved into emerging engineering technologies and the use of artificial intelligence in tracking moving objects, for which we are intending to apply to solve the problem of galamsey. Artificial intelligence being applied in solving ECG's problem of power theft that ECG is unable to resolve.
Health facilities all over the world generate waste. About 15% of the waste generated by healthcare activities are classified under hazardous waste. Healthcare facilities generate on average between 0.2 and 0.5 kg of hazardous waste per bed per day. The medical waste of prime concern to medium and small healthcare facilities are infectious waste and sharps. These wastes are waste contaminated with blood and other bodily fluids. Each year, an estimated 16 billion injections are used globally, and waste from injections contain potentially harmful microorganisms which can pose risk of infections like hepatitis B, hepatitis C, and HIV/AIDS, and injuries to health workers and the community at large if not managed properly. In Ghana, the most common mode of medical waste disposal is by landfill, which is considered unsafe. To meet international standards, the World Health Organization (WHO) introduced the Injection Safety Incinerator program to address issues of disposal and eradicate the risk associated with improper management of medical waste in the country.
WHO Ghana and Ghana Health Service contacted the CSIR Institute of Industrial Research, in particular the Materials and Manufacturing Division, to begin to produce locally made refractory bricks for construction of incinerators.
Over the years, the Council for Scientific and Industrial Research, Institute of Industrial Research, has developed several heating processing technologies, including incinerators with operating temperatures reaching 1000 degrees Celsius for managing hospital and municipal waste. These technologies have been deployed severally across the country. The mechanized incinerator was installed to manage hospital and waste generated during manufacturing. Advantages of the mechanized incinerator. The double wall with refractory bricks ensures greater heat retention with a thermal efficiency of about 80%. The front loading enables safe operation and minimizes heat losses through the door during the charging process. A forced draft system together with a chimney is designed to ensure optimum air injection to support complete combustion and the release of less harmful gases. The mechanical charging system is designed to ensure safety and reduce drudgery during waste charging in between cycles. A charging rate of 75 kilograms at 10-minute intervals ensures the disposal of 3.5 metric tons of combustible waste in 8 hours with a destruction efficiency of around 90%.
The RTKCs are set up to help these local manufacturers who design and manufacture the cook stoves so that they will be able to get designs that are firstly specific to local needs, and then designs that do not consume so much fuel and then do not give off emissions that will hurt the climate. So that's why the RTKCs are set up. The WBT lab is where we start with manufacturers when they bring their stoves for testing. The WBT is supposed to simmer the cooking process. We check the amount of fuel that the stove is using and then the emissions that is coming out of the stove. So the emissions that we test for are carbon monoxide, we test for carbon dioxide, and then particulate matter. The particulate matter has different sizes, but the one that we check for is the one that has the aerodynamic diameter of 2.5. So we check for PM 2.5. Whilst we are doing the testing, we are also checking the parameters of the stove, the air inlets, the combustion chamber, the design of the combustion chamber, the gap of the pots. All these are to inform us so that if there are any modification that the manufacturer needs to make, then that is the recommendation that we give, so that they go and then do the recommendations, implement them on the stove, and then bring it back for testing. And then we have the fuels lab. As I said before, when you bring your stove for testing, the stove works with the fuel. So we need to know the parameters of the fuel as well. So that is what we do at the fuels lab. So from there, we have the ISO testing lab. So after we have recommended some recommendations for you to implement on your stove, then when you are sure that you have the final product, then we bring it to the ISO testing lab to test it for you. That is the final test that you do. So the ISO is also similar to the WBT, but that one is also simmering the cooking process, but then the parameters are slightly different. So you are simmering it for different power levels. So you do low power, you do medium power, and then you do high power. So those are the differences. But then we still also check for the carbon dioxide, carbon monoxide, and then the particulate matter. We have another additional gas that we check for, and that is the black carbon. The black carbon is what is contributing mostly to climate change. So we are very particular about that. So when you bring your stove for testing, those are the gases that we test for. So the ISO is an internationally accepted protocol that we use for testing. And we are confident of our results because we do an inter-lab comparison with other labs that is not in Ghana, some in the US, some in Uganda, to be able to know that if you bring your stove here for testing and we give you the results, if you take it to the US for testing, you'll be getting similar results within the same environmental conditions that exist in this lab. So that is the parameters that we get from the ISO testing. So apart from the testing that we do, we also do an audit. If you have briquettes that you are making, if you have a charcoal production that you're doing, what we do is we advise. So if you bring us into your operations to do an audit of your process, then we'll be able to inform you as to what you are doing right, what you are doing wrong, what you need to change and all that, so that your whole process is audited. And then we give recommendations to make your products very good, especially if you are using it in a cook stove. So those who are doing their briquettes, those who are doing charcoal, those who are doing other waste products and turning them into briquettes or pellets. So at CSIR-IIR, these are the labs that we have available. We have an LI in Ghana that has been passed, and that is the standards and labeling for biomass cook stoves. So if your cook stove do not meet a certain standard that has been set by the Ghana Standards Authority, then your stove will no longer be on the market. So you need to meet these specifications and labeled before your stove can be on the market. We have been given 2 years for those that are existing currently to be able to modify their designs to be able to meet the Ghana standard. So CSIR-IIR RTKC is open to all manufacturers who have their cook stoves on the market to work with us to be able to bring their stoves up to the Ghana standard so that they can stay in business.
Remotely controlled solar irrigation system. One of the major problems that inhibits growth in the agricultural sector is the heavy reliance on rainfall as the main source of water for planting and the lack of irrigation facilities. In Ghana currently, there is a shift in the rainfall regime toward a longer dry season and a reducing rainy season. The net effect of these changes is a decline in yield, which ultimately affects the livelihood of farmers. Ghana is, however, blessed with inexhaustible resources for solar energy, which can be tapped through solar water pumps to facilitate all-year farming in Ghana. A vast potential exists for exploring the use of ICT in agricultural development, and one of such applications is by leveraging on ICT and Ghana's abundant sunshine for crop production. It is against this backdrop that the Institute has developed and tested a mobile phone application that remotely controls a solar-powered irrigation pump in the Ghanaian context. The mobile application has a multi-purpose interface for sending instructions such as turning the pump on and off for irrigation and also viewing water flow data. Data of flow rate is displayed instantaneously on mobile applications and can be accessed or monitored remotely from any location. This technology has successfully been piloted and offers farmers in the country the opportunity to minimize the over-dependence on rain-fed agriculture and provide sustainable technology due to inexhaustible solar energy resources. Benefits. The piloted technology is sustainable and therefore suitable for all year-long farming. Due to its simplicity in operation, the mobile application can be operated by farmers at all levels and at all ages. It will also help reduce farmers' workload and make farming more appealing to the youth and women. Save money, water, and time. It has the potential to increase annual yield by 2 to 3 times more as compared to the conventional way through all year-round farming.
My name is Engineer Michael Wilson, a Chief Research Technologist and the Head of Electronics Division at CSIR-IIR. The crux of our mandate at CSIR-IIR is to provide scientific and technological information to multiple stakeholders, including research scientists, industrialists, and also to policymakers as a contribution towards national development. In doing so, we work with multiple stakeholders and partners to package information in format that will be readily consumable by these stakeholders. This year, we have worked with multiple stakeholders, but we want to talk about our partnership with ICRA in the development of what has come to be known as the Agricultural Data Hub, for short the Ag Data Hub. The Ag Data Hub packages information using an ETL engine and transforms them into meaningful dashboards and APIs that can be used by different developers and stakeholders. The hub also makes available data that has been collected by multiple institutions and makes them available in visualized format for policymakers to easily understand what is happening on the ground. The visualization and dashboards are created by a team of in-house experts, including data engineers, data scientists, data analysts, developers who work together to package this information in formats that have been demanded and requested by our partners, who include scientists, policymakers, and industrialists. The data can be visualized on our dashboards, which are publicly accessible through the Art Data Hub, which will be going live by the end of this year. As the accounts will say, Yansa inni baako for trim, which means wisdom does not reside in the head of one man. Our scientists have created a dynamic portal where people, users, can interact with data themselves and create dynamic dashboards and visualizations that suit their own criteria. In this way, we allow them to interact with the data and create their own meaning out of the data. After the visualizations, our team of developers take over and develop useful tools and advisories that can be used directly by our end users, including farmers, extension officers, different people, including the transport sector. What we are seeing now is a weather forecast tool that was worked or is being worked on hand in hand with the Ghana Meteorological Agency to provide a 5-day forecast for the community. To improve the forecast that we receive, 360 geolocations have been selected, and what our team is doing is to match forecast against actual temperature and rain patterns with the idea of working towards using machine learning and artificial intelligence algorithms to improve the weather forecast data. Our developers are well versed in different and multiple programming languages, including Java, Python, PHP, and whatever you can think about. Our team of developers work with on-ground experts to develop tools that are on demand by our end users, who are mostly extension officers and farmers. One of such tools is the cropping calendar developed for the northern region of Ghana. The calendar allows a user to select a value chain, select their location, and the tool generates a sequence of tailor-made advisories that fit the purpose. One key thing is sharing information across stakeholders. Using our portal or the Art Data Hub, users are able to share information easily. For example, data that has been collected can easily be shared with other partners, and this will greatly reduce the amount of money and cost spent in collection of data. Here, a scientist is able to easily share their data with other scientists or other institutions, and the data can also be unshared. That is the beauty of it. Once there are partnerships, we can easily share data and reduce the cost of data collection. Not only data can be shared, but also resources and messaging. Here we provide a portal where users can send message to classified groups. An example is sending a message to Upper East maize farmers, which will automatically load all farmers in that group. We also allow the sharing of resources, which include videos or certified videos that support our end users, including extension officers and farmers directly. Welcome to the CSIR-IIR Makerspace, a co-innovative working hub open to the general public. In the past, the Makerspace has collaborated with the OPEX Prize, with the Ghana Robotics Academy Foundation, and also with JA Africa to help entrepreneurs build their skills and prototype their ideas. Here we have all the equipment you can think about, ranging from 3D printers to CNC machines to robots and other equipment that you would need to fast prototype your idea. The Makerspace has been managed by the CSIR-IIR Electronics Division for the past 3 years and has achieved a lot under its belt. The Makerspace operates under the Electronics Division, whose objective is to research and develop the next generation electronic equipment and robotic tools to support industrialization. Currently, there are a couple of activities and research works ongoing, including the design of an autonomous ground vehicle with multi-purpose functionality. The division is also researching on the use of artificial neural networks for plant disease detection. There is also work ongoing on the use of a bio-inspired algorithm to reduce the latency in IoT applications. Our doors are always wide open, and our team of experts are waiting for you to say Akwaba to CSIR-IIR.